Hello everyone. So today we are going to solve a very interesting and practical problem number 1870, minimum speed to arrive on time. And the problem says we are given a floating point number hours representing the amount of time you have to reach to the office. To commute your office you must take n trains in sequential order. You are also given an integer at a disk of length n where dist of I describe the distance in kilometers of the ith train. Each train can depart on an integer hour, so you may need to wait in between each train ride. For example, if the first train ride takes 1.5 hours, you must wait for an additional zero point 0.5 hours before you can depart on the second train ride at the 2-hour mark. Return the minimum positive integer speed in kilometers that the train must travel at for you to reach the office on time, or -1 if it is not possible on time. Tests are generated such that the answers will not exceed 10:7 and hours will have at most 2 digits after the decimal point. Okay, so from reading the problem, the information that I can gather is we have been given some, so we need to find this speed so that we can reach our office in minimum time, right? So, and our speed region is starting from 1 and it goes up to 10:7. And so this is the minimum positive integer. It is given in the problem. We have a minimum positive integer, so which is 1, and the maximum positive integer that needs to be handled in the problem is 10:7. Okay, so we are going to use that information. So these are the minimum and maximum speed. So this is the minimum speed at which I can travel, and the maximum speed at which I can travel is 10:7. So looking at it, it looked like to me a straightforward binary search. Yeah, we need to find a speed which is going to be somewhere in between these that will optimize our problem. So what will I will do? I will keep two pointers, one left over here, one right over here, and then I will check the mid, and at the mid I will calculate the speed. I will calculate the time at this mid speed, and I will check if my speed, this mid speed, is less than the total numbers of hours that we have. And if it is less than the hours, so for example, let's say we pick this second example. So here our distance is 132, and the total distance, summation of distance is total is 6. So let's say I start with the speed of 1. So in that time my function value is 6 divided by 1, which is 6 hours. So, and I want to reduce this 6 hours to 2.7 hours. So I know that at this speed I will reach office at 6 hours, and but I want to be within reaching the hours within 2.7 hours. So what I will do is, like, I need to look for another value. So I will increase my, I will, that I definitely know that my search region between left and mid is not feasible. So I will update my mid and take it towards the mid, in which I know that this is the region where my next speed would be. So similarly, I will initially check with the right speed, which is f of r. So that is 6 divided by 10⁻⁷, which is less than, definitely going to be less than 1. So I need to increase this speed. I need to increase this I need to decrease the speed so that my time would be increased, and I reach the office in 2.7 hours. So what I observe is that my time is basically distance upon speed. So this time is my function of speed, and which is monotonically decreasing, and I'm situated over here. So this function is like this is L, this is R, and these are the values FL, and this is F of R, and I need to reach to this optimal speed, and for that I got the conditions like if the F of mid is less than the F of R's, the total number of R's that I have, so that let's say that is R, so I need to update my right pointer. So I will be looking in this region. So when my mid is, so let's say we are here and this is our mid. So at this mid, if my numbers of R's, which are, let's say this, so at target, this is the R's. So this mid is definitely less than the R's. So I'm sure that this speed is not going to help me. So I will discard this region and I will update my right pointer towards the mid. So I know that this region is not helpful for me, and my solution would lie in this region of between L and R, and I need to find a new speed. So in this region I will update my R towards the mid, and if I found one value of mid where it is greater than R, then I know that in this region I need to update my L towards the mid. So that would be approach for solving this problem, and in the end we'll return just the answer which will have the appropriate value. So now let's get into the coding part, and I'm going to write exactly what I have told you. So as said in the problem, we have one left and we have one right. So left is initialized at 1 and right is initialized at 10 raised to 7. So we'll just add 1, or this could be any random number, so that I have the region, and I will initialize my answer with the impossible value. And now we'll start our binary search, and we'll look for the very first time. We'll calculate the mid, which is L plus R by 2. So this is the floor division, which gives you the quotient out of the 2, and I need that. And we'll check if this function of mid is less than the R, which is our time. So we need to update our right towards the mid, otherwise we'll update our L towards the mid plus 1. And so if we found this valid region, so we'll say that our answer, this is the mid value which I'm looking for, and we'll return this mid value as our optimal speed. Now we need to write one function to check for the problem definition, and it says in the question that the each train only depart at an integer hour, so our time is going to be an integer. So what we'll do is we'll start writing this time function, so function of which is basically speed, and we'll check the what is the total time. We will initialize the total time with 0, and we'll look for every distance in the distance array that we have. We need to go up till the last one element before the last, and there we want the integer values of these to calculate our time. So that would be distance upon speed, and in the end we want to add the last value just that is as it is that it is. So that is distance minus 1 divided by speed, and this would uh, do our problem. So now let's run our solution and see how it performs. Oh, we don't want a space in between. So it has been accepted. Now let's run it for different test cases. Now that has been accepted as well, and let's now submit our solution and see how it performed. So it is fast and it is running great. So the time complexity for this problem is going to be O of log n log of, so we have two time complexities, so O of n times, so the O of n times is for traversing in this, we are traversing the distance list, so for that it is O of n, and we are doing binary search, so that is log of r minus l that we have. So the overall time complexity is going to be O of n into log of r minus l, where r and l are the boundaries that we wrote, and the space complexity, we are not using any space, so space complexity is O of 1. So that would be the solution for this problem number 1870, and I hope you guys are liking my solutions, and if you have any particular problem, let me know and I can have a look. And please like and subscribe to the channel. It helped me in creating more awesome content for you. Thank you.